Okay, today's lesson is U2A3 and it is torque. So we are in mechanical advantage, and when we talk about mechanical advantage, you'll often hear the term torque. Now, torque is a turning force exerted on a rigid force around a fulcrum. So the fulcrum is the point where lever is supported. If you're not sure what torque is, I would highly suggest you go onto YouTube, watch a couple videos on what is torque. You'll see some great examples in there. So in torque, what we're trying to do is we're trying to move a load. And we do this by having a rigid post, and we exert a force down on it. Now the way this formula works is the greater the force we push down on, the more load that we can move. Also, if this distance is greater between the fulcrum and where our force is, then we have a greater advantage. So if you tried this, if you tried pushing down right here, you couldn't lift nearly as much as if you push down here. The further out you go, the more you can lift. So if we extended this rigid pole and we put the force down here, we could lift more. Now, the last thing that's important here, and we always make this assumption when we do the problems, is that if the force is at 90 degrees to the rigid pole, then you're going to have more torque. If you're not right at 90 degrees, you lose some of your torque. So the formula for torque is force times distance. Remember, torque is measured in, or force is measured in newtons, and distance is measured in meters. What we come to next is something called law of the lever, and you guys are going to be working on activity U2A3, law of the lever. So you're going to do an activity there, and what you're going to do is you're going to look at effort and load. So when we talk about load, remember this load also has a force because this load is pushing down and there is a distance here. So the FL and the DL is the distance the distance that the load is away from the fulcrum. And remember, the fulcrum is the point by which this lever pivots on. And we also have to take in consideration the distance. Now, the effort torque is what we just talked about. It's the force that you're pushing down with, and it's the distance from the fulcrum to where your effort is. Now, what the law of the lever says is that we can make a formula up that says FE, force effort, distance effort, equals force lever, distance lever, because when a lever is in equilibrium, meaning when it's balanced, it's not moving, effort torque is equal to load torque. Now, what we've done here is if you get any problems to do with torque on a quiz or test, all I've done is rearranged this formula right here into 4 different formulas. So if they said, what is the equilibrium force in this problem, you would use this formula and you would just substitute everything in. If they said, how far is the load from the fulcrum, distance load, you would just put this information in to solve this problem. Folks, do not forget, you have the lesson to do. I believe there are 3 pages on the lesson, and then there is going to be an activity to work on.